But if I had x plus 5 squared, right? So because we are x plus 5 times x plus 5, it's x squared and it's 25. But remember, on the inside, I'd get a 5x and another 5x. So do you see how they have 5 times x, but then they put the 2 because you're going to have 2 of them? All right, so this becomes a perfect square trinomial. And you'll notice that if I take half of 10, what would be that? What would be that? What would that be? 5. And I square 5, we get 25. That's what this is telling you right here. That is basically the formula, if you will, for creating a perfect square. And they give it to you in this box right here. But that's what they're telling you. Whatever your middle number is, whatever that b number, the number in front of your x term, you take half of it, because remember there's 2 numbers, and then you square it to get this number. But because it's an equation, you'll see you have to add it to both sides. You will have to add it to both sides. This is factoring in. Okay, so it'll make more sense once we do it a couple times. So down here, all we're doing in this first example is they're giving us x squared minus 8x plus what? What would that number be for it to be a perfect square? So here's what you do. Step 1, take half of b. So what is half of negative 8? Negative 4. Now the negative is really moot because the second step is squaring it. So whether you have a negative 4 or a positive 4, when I square it, what's it going to be? 16. Positive 16. So that c, the number you're going to add in, will always be adding because it's a perfect square. So you're squaring it, so it's always going to be a plus. So the number we would add to both sides would be 16. So take half of it, square it, and then add it to both sides. That's what we're going to do. So now down here, we're actually going to use that process to solve the equation. Okay, breaking down over here, there's 7 steps, but some of them are so small they almost don't need a step of their own. But let's go through this. So the first thing we're going to do, notice that is not a perfect square. Can't be. 5's prime, right? So first step, you want to get the x squared and the x alone, meaning all I want on this side are these 2. So we're going to move that constant to the other side. So what do? Add 5. So now I have x squared plus 4x. I'm going to leave a space equals 5. I'm going to leave a space because now we are going to figure out what number we're going to add to make on the right, or to make on the left side a perfect square. So b is 4. Half of that is
2.
Square that. 4. So we are going to add to both sides a 4. Because in order for an equation to remain equal, whatever I add to one side, I have to add to the other. So now let's factor, and this says add it to both sides. That's what we just did. Factor the perfect square trinomial. So this is a perfect square of what? X plus 2. By the way, it's always going to be the number you get when you took half of it before you squared it. So when you take when you take half of the number before you square it, that's the number that's going to go in there. Yeah, Logan.
So could it ever be like x minus something?
Could, yes, it could. If this were a negative number right there,
Yeah.
yep, it would be. Okay, so now we're gonna solve it by using the square root. We're going to undo that square by taking the square root of both sides. So now on the left side, all I have is x plus 2. But on the right side, careful. Remember, when I take a square root, it's a positive and a negative. And right there, remember, that's why we have 2 answers. Because we're going to have one answer when we add it, and one answer when we subtract it. So now I'm going to write it like this, and hopefully you guys are okay with that. So x equals a negative 2 plus 3 and a negative 2 minus 3. There's our two roots. So what are they? What's negative 2 plus 3?
1.
And what's negative 2 minus 3? Negative 5. And there are your two answers. That's your two solutions. Another word they use, two roots. It's where it's going to cross the x-axis, and they also call them zeros. So solutions, roots, zeros. All three mean the same thing. All right, let's try another one. Flip your paper over. On the back side. Okay, so this one is a little bit more complicated. Why? What's different about this third example?
There's x squared. Yeah.
We got a coefficient. So here's what it looks like. It doesn't really matter what you do first. Do you want to add the 5 to the other side first?
Yeah.
Okay, so let's do that. We get 5x squared minus 80x equals 5. So now before equals, right? Because I added 5. Before I can take half and square it, I have to make sure that is a 1. So how do I get rid of the 5?
Divide.
Divide everything by 5. Everything. God bless you.
Thank you.
So when I say everything, each term, so this is x squared, the negative 80x becomes negative 16x, and then now we only have 1 on the right side. Now we can follow the same pattern we did before. Take half of negative 16, which would be negative 8, square it. We're going to add 64 to both sides. Equals 65, right? Because 1 plus 64. Now let's factor. We know it's a perfect square, and here's your minus sign, right? So now it's going to be x minus a number. It will be minus 8. Now when we solve this one's different than the one we just did. The one we just did on the front side gave us nice, pretty integers, which rarely happens. Usually this is what happens. Okay? Because what happens when I take the square root of 65? It's definitely not a perfect square, is it? So here's how I'm going to write it. I'm just going to leave it x minus 8 equals plus and minus square root 65. We're going to simplify it later, but for right now, I'm just going to leave it written like that. What's the last step going to be? Add 8. So my two answers are 8 plus and minus the square root of 65. Now here is where you get to use your calculator, and as it says, I kind of went past it. I didn't say it. Round to the nearest tenth. Here's where you can round to the nearest tenth. Now, in some cases, I haven't come by it. I know some of you working in Alex. Some cases, they'll just let you leave the answer just like that. But for us, we're going to practice punching that in our calculator and rounding to the nearest tenth. So who's got my first one? It's going to be like 16 point something, right? When I add the square root of 65?
16.06, and that's rounded.
So is it 0.1? Because it says to the nearest tenth, right?
Oh, yeah, so 0.1.
0.1. And then 8 minus the square root of 65, going to be ever just barely negative, right? And those are our answers. Now, I believe on Alex, correct me if I'm wrong, Bryce, I just helped you with this. They make you go to the nearest hundredth, right?
Yeah.
So 2 decimal places. Same, you're doing the same thing, but they make you go 2 decimal places. Okay? So sometimes they end with nice, pretty integers. Not very often. Most of the time, it's going to be an irrational number. This is irrational because the square root of 65 is irrational.
Ms. Burris,
Yes.
hey, would you send Logan Culhane to the front office quick?
Okay. All right. Let's do this last one right here, and something interesting is going to happen. We'll notice when we get there, but let's just solve it like we did all the other ones. Do you want to divide by -2 first, or do you want to move the 18 over there?
Move the 18.
Okay, so if I add 18, I'm going to get -2x squared plus 8x, and now it equals a positive 18. And now we got to get rid of that coefficient. So divide everything by -2. So I get x squared. We get -4x, right? Because the positive 8 divided by -2. And it now equals -9. So now we do the same thing. Take half of the b, half of 4 is 2, and square it.
Wait, isn't 9 a perfect square?
What's that?
Is it 9 perfect?
It is a perfect square, but we're going to add something to it. Oh, you're right. Oh, it was a perfect square, but it wouldn't work with the 4. Nothing. He was saying if we left the 9 over here, 9's a perfect square. And he's right, except it would have had to have been a -6 in the middle for that one to work. So we're going to make it a perfect square. Good point, though. All right, so half of 4 is 2. 2 squared is 4. We're going to add 4 to both sides. God bless you, or whatever. Excuse you, I guess. Right? Okay, so over here, I'm going to factor it. I get x minus 2 squared. Now, before I go on, even if you don't see this now, you'll see it eventually. When I square a number, what kind of answer do I get? What? A binomial. Well, but if I square any kind of number, what kind of answer am I going to get?
Positive.
A positive answer. Look what they just look what we have right now.
No solution.
I don't care what I put in there for x. If I square it, it better equal a positive number. And it doesn't, does it? So here, this is what happens when it doesn't cross the x-axis. So this is a parabola that's either above the x-axis or below the x-axis, and it doesn't have any x-intercepts. So even if you would have done this, I'm hoping that at this point you'd say, ooh, whoops, I can't do that. Or even you go on and your calculator says error, right? Because we can't do that. It is not a real number. So no real solution. Now, like I said, as you move on in algebra, you're going to find out that there's a way we can do that by introducing a new type of number that isn't real. It's called imaginary. But we got to talk about that next year, or somebody's going to talk about that with you. Okay? So, let's use what we just were doing by completing the square and do, I don't know, how about a word problem?
Do we have a word problem or
Maybe. Okay? It says the senior class at Bay High School buys jerseys to wear for football games. Rock on. At least they're not wearing t-shirts, right? The cost of the jerseys can be modeled by this equation. So cost equals 0.1x squared plus 2.4x plus 25, where C is the amount it costs to buy X jerseys. All right? So C is the cost. X stands for the number of jerseys. How many jerseys, so what are we finding? X, right? Can they purchase for $430? And that's C. So we're going to put $430 in for C. And we're going to solve. Now, how many of you said, oh, dear Lord, we got decimals in there. How are we going to do this? Right? Well, go ahead. Let's go ahead. Can we get rid of the C? Can we get rid of the 25 first? And we get what? 405 equals 0.1x squared plus 2.4x. And we are going to complete the square, but what's the first thing we have to do? I got to get rid of that coefficient in front of the x squared term. So divide everything by 0.1, which really is the same as multiplying by 10, because it's 1/10, dividing by 1/10. So this becomes 4,050. This is x squared, and this becomes 24x. Gets rid of our decimals, right? So let's complete the square. Half of 24? 12? 12 squared? So I have to add 144 to both sides. And over here, what do I get? 4194. Let's factor our perfect square trinomial. What's it going to be? What's half of 24? 12. It's always the number it's going to be. Now solve. First step, from this point anyways, take the square root. I'm going to leave that square root alone because I'm pretty sure it's not a perfect square. And we're going to have to subtract 12. So my two answers are negative 12 plus and minus the square root of 4194. So our two answers. Get your calculators out. Here's where we get to figure it out. We're going to take negative 12 plus the square root of 4194. And what do we get? Give me one decimal place. Actually, it's, yeah, one decimal place. Now, here's my question to you. I'm talking about the total number of jerseys I can purchase with $430. So 52, because we can't round up, right? Because if I rounded up, I would not have enough money. So 52 jerseys. And I'm actually done. Do you know why? Because the other one's going to give me a negative answer, and that doesn't make any sense. Right? All right. The last example problem, and probably I think I like these the most because I just like geometry. So it gets to tie in geometry with this. So the area of the rectangle is 144 centimeters squared. What are the length and width of the rectangle? Well, over here it's drawn. The length is 3x and the width is x minus 8. How do I find the area of a rectangle? Multiply them. So I'm going to take 3x times x minus 8. And that will equal 144 because that's what they told me the area was. So I got 3x squared minus 24x equals 144. And a 144 is a perfect square, but if I put it on the other side, it'd be negative, so it's not going to work, right? First step. Before I complete my square, what do I have to do? Divide by 3. Everything dividing by 3. So I got x squared, I got 8x, and 144, 48. Sorry, I didn't hear you right away. Now take half of our b, which is 4, square it. We're going to add 16 to both sides. Factoring my perfect square, going to be that. And 48 plus 16 will be 64, right? Well, that's so nice, because what's going to happen? It is a perfect square. When I take the square root, I'm going to get plus and minus 8. And when I add the 4, I got x equals 4 plus and minus 8. In other words, I got 12 and negative 4. Which one can I throw out? Yeah, because does that make any sense for a negative 12? Probably not. So if x is 12, what are my width and length? So 3 times 12 would be 36 centimeters, and 12 minus 8, 4 centimeters. So oftentimes in the word problems, you might get an answer that in real life doesn't make sense. Like in the jerseys, you can't buy negative jerseys. You can't have a negative length. So you can throw that out. All right, your assignment, I think, is it on the back? Oh, no, it's not on the back. I got to